Hello, illustrious radiation chemistry graduate. Let's go. The Medusa activated by itself for unknown reason. This must be the work of an enemy Y-Man. So more excuse to hurry up the process of getting to the moon to get to Y-Man. In that process, Senku made TV camera from selenium, arsenic, and tellurium, mined from Kagoshima. TV camera is useful for watching the Medusa under surveillance and observing the moon from a satellite to scout Y-Man's location on the moon. To power the satellite camera in space, solar panels are also created using gold and selenium, and it has magnesium fluoride as anti-glare coating. Since in 2 consecutive chapters we see selenium being useful because of its interaction with light, I decided to make these 2 chapters in one video. First, we got selenium, arsenic, and tellurium from Kagoshima mines. The ore, according to the manga, is not selenium ore, but selenium-bearing silver ore. For 2 out of the 3 elements, namely selenium and tellurium, unlike the metals we encountered in early game like copper, iron, or mercury, and late game like those in Super Alloy chapter, minerals containing mainly the 2 elements are not common. Usually, these 2 are found substituting ores that contain sulfide, seeing that sulfur, selenium, and tellurium are all in the same group, so similar chemistry. Some copper ores and some silver ores contain sulfur, so some may be substituted with selenium and tellurium. In the later stage of copper and silver purification, electrolysis is done to push the purity of each element closer to 100%, because smelting is not enough. And in electrolysis, the less pure copper or silver used as anode will be used up, leaving something called anode sludge. This sludge is where we get the tellurium and selenium in form of noble metal selenite and telluride. Then, with this sequence of treatments and reagents, the elements are obtained. For arsenic, there is a mineral called arsenopyrite that can be used as source of arsenic. It is structurally related to pyrite, and as you can see, arsenic is another element that replaces sulfur, despite being in different periodic table group. The arsenopyrite can be heated in absence of air to obtain elemental arsenic immediately. Or if heated in air, it makes arsenic trioxide, which can be reduced by carbon, so using coke just like iron. The 3 elements are used to make a part of video camera tube. The video camera tube is actually Hitachi's design, as in the company's trademark, and named Saticon in 1973. There are other kinds of video camera tube with different material, but the one we see in the manga is the one with selenium. Selenium is used because it exhibits a phenomenon called photoconductivity. The resistance of selenium depends on the light hitting it. Electronics is not my forte, so forgive me if I'm wrong, but if I understand it correctly, there is a cathode ray tube on the other side of the selenium. The CRT shoots slow electrons to scan left to right in a line, top line to bottom line, and that makes a circuit. With the resistance of the selenium changing whenever the spot is bright or dark, the voltage of it will also be different, and that changing voltage is the signals used to reconstruct the image. As the photoconductive material in video camera tube, selenium is used again as solar cells and panels. Solar cells need semiconductor that can show photovoltaic effect, and selenium is probably one of them. We have heard this before in chapter 205. The semiconductor we usually use in real life nowadays is silicon, and that's the impossible hell mentioned in chapter 205 because of purity requirement. Such the requirement of semiconductor, said semiconductor must make a p-n junction to work. For silicon that has 4 valence electrons, the crystal can be intentionally given impurities, aka dope. One of the impurities is usually phosphorus, which has 5 valence electrons, meaning it has extra electron, so negatively charged particle can move, so it's n-type. The opposite type usually uses boron, which has 3 valence electrons, meaning it lacks electron, so we can consider it to have positive holes, so p-type. In the manga, we have the junction selenium and gold. From both of their atomic electron configuration, I guess gold is the positive one. When the two semiconductors meet, some of the electrons in the n-type move into the positive p-type, thus forming an imbalance of charge, and the area is called depletion region. When light hits a neutral atom in depletion region, it knocks the electron out. Because of the electric charge in the depletion region, the electron flows toward the n-type semiconductor, which can be collected by the electrode there, and flow to the rest of the circuit. The light must be absorbed by the semiconductor for the solar cell to work. To protect the semiconductor, there is a layer of glass in front of the photovoltaic circuitry. However, the glass may also reflect some of the light. To prevent that, an anti-reflective coating is applied to the glass, and in the manga it's magnesium fluoride. We have met magnesium already way back in season 2 as the flare, and fluoride and sulfurina must be a shorthand of hydrofluoric acid, HF. If we mix magnesium with HF, I don't think the result will be pretty, because the magnesium gets attacked by the acid and probably will leave insoluble magnesium fluoride on the surface of the metal, leaving unreacted magnesium metal inside. I think it's better to, at the minimum, dissolve the magnesium metal into magnesium cation using anion that's compatible with magnesium, like this paper that uses magnesium acetate and HF in the beginning, which forms the magnesium fluoride, only to redissolve it in hydrofluoric acid and reform it to get nanoparticle-sized magnesium fluoride. Once magnesium fluoride is obtained, to apply it to glass, there are many ways to do it. Wikipedia says physical vapor deposition, so just like CVD used back then to make diamond, but without the chemical decomposition. Another method, according to the paper I mentioned just now, is by deep coating. Disperse the magnesium fluoride in ethanol-ish solvent, dip the glass, and dry it in oven. I hope my physics explanation is correct. The way magnesium fluoride works as anti-reflective coating is that magnesium fluoride has refractive index between air and glass. There is an equation which connects the intensity of light reflected to the indices of the material involved. And from that, the best thing to do is to have as little as possible the difference of refractive indices between air and the coating, and between the coating and the glass. In conclusion, selenium and tellurium has no particular ore, but they usually replace sulfur in copper or silver ore. Because of that, they can be found from the byproducts of copper or silver purification. The arsenic has a mineral that can give elemental arsenic in a few steps. Those three elements are made into photoconductive material in silicon video camera tube. Because of the photoconductor resistance fluctuates from the light hitting it, the voltage also fluctuates, and that can be interpreted as signals to be broadcast. Selenium starts again in the next chapter due to its photovoltaic property, and together with gold they can make a p-n junction, move electrons whenever light hits it, and form a solar cell. Magnesium fluoride synthesis is a bit concerning, but that aside, it can act as anti-reflecting layer in front of glass because of its refractive index. That's all I have for now. I'll let YouTube tell you what to watch next. I hope YouTube gives you a good recommendation.